Hey, Daniel, do you want to check your audio? Daniel?
Hi, Sumit. How are you doing?
Good. Yeah, doing all right.
It's good.
Uh,
How's
Christine, is it
my...
okay sound-wise? I think I can hear you well.
Okay. Just let me know if I should.
Daniel, whenever you're ready, you can go ahead and share your screen and it'll remove my slides.
It says I can't start screen share while someone else is sharing.
Let me check.
What if Okay, let's try that. Can you see the title slide now?
Yes.
Yes.
Wonderful.
Okay, you can go ahead and get started whenever you're ready.
Okay, great. Right. So yeah, thanks for joining the somewhat rearranged Lenaro Connect session. I'm here to talk today about the Wayland and Weston projects, which have been quite intertwined, and what we've learned from the last 8 or so years of actually having shipped these in production. And hopefully some takeaways for you for your own projects to see if there's anything you can learn from us. So I'm the graphics lead at Collabora. I've been at Collabora for about 11 years, and for the last 8 years or so, I've been actively working on Wayland together with not just the community, but a lot of the rest of our team at Collabora as well. So yeah, this talk, it's not actually about the technical details really of Wayland and Weston. It's about what's happened over the past 12 years and how Wayland as a project has been shaped since 2008. And if you look at the ecosystem in 2008, it was the giant, unchallengeable behemoth of X11, and then a lot of, for embedded systems in particular, and a lot of the systems that Lenaro members target. We had things like DirectFB, Qt's QWS. That was the landscape really for other Windows systems, which Wayland was effectively competing with. But now if you fast forward to 2020, things are completely different. X11 is obviously still around, and to be honest, I don't think it'll ever die for better or worse. But apart from that, especially in the ARM and embedded world, Wayland is the Windows system of choice. It's now the default Windows system for desktop and mainline distributions as well, generally. And obviously to get to that position, we've made a lot of good choices and done a lot of good things along the way as a project. And some which were not so great. We've definitely made some mistakes along the way. So we're just trying to run through some of this history and some of the takeaways to see if your project could learn anything from the history and the evolution of Wayland. And probably to understand a lot of the context, I thought I'd run back through the overall history of Wayland as a project, and the various stages of evolution it's been through to help understand the context in which some of the choices and decisions were made. So firstly, if we look at this as a kind of prehistorical age, in late 2008, Christian Hogsberg, otherwise known as KRH, made his first commit to the Wayland repository. It described a nano display server, and it did have the object model that we know from Wayland itself, and a lot of the same protocol, but a lot of things were completely different. Throughout 2008 and 2009, it continued as a very, very small sort of one man's interest project. The only real activity other than Christian is Phoronix noticed the Git repository in October and wrote it up. I did go back through and read some of the comments on that article, some of which were incredibly prescient and others of which were not so much. But through 2008 and 2009, it was really just Christian's own personal interest hacking, with Ray Strode being about the only other contributor of note. And then it took until really about 2010 when you started to see Wayland as we know it begin to take shape. So we had things like the protocol being generated from XML, which has made it much easier for the extension system that we have today. And we also had a kind of the start of a desktop protocol and the buffer management by August 2010. So that is really the starting point of Wayland as we know it today. Would have begun just under 10 years ago now. And then in October 2010, unfortunately, all the history before then is lost as it's in a now deleted Google group. But this is the first still available public mailing list is when Christian moved Wayland to freedesktop.org, and the repositories and the lists were created, and you could start to see a lot of public discussion and more contribution. And then in the kind of the Stone Age, I've put it as, not about myself, but just about a sort of very rudimentary beginning to take shape. So we see through 2011 that we have Weston, the compositor, running on top of Wayland itself in the nested mode for the first time. And then Weston moving out to a separate repository from the Wayland core as well. And that was quite important because it acknowledged that there would be multiple implementations of Wayland, and more importantly, that Wayland itself was ready for multiple implementations and for people to take it outside of this sandbox and try it and really implement it. And sure enough, already by March, the free box shipped by a French internet and set-top box provider called Free had already shipped out to millions of users based on essentially an unreleased version of Wayland. And throughout 2011, we continue to accumulate a lot of things taking shape, like Wayland for hosting X11 clients within a Wayland session. And then by the end of this period, in very early 2012, around FOSDEM, we can see Wayland really solidify into the roots of what we know now. So there was a meeting of around 15 Wayland contributors happened just before FOSDEM that year. And one of the outcomes is we had this 0.85 release, which was the first real release of Wayland in 2012, and that had almost all of the concepts that we know today. And then, yeah, we move into the Bronze Age, where we're not so much just banging tools together, but we're starting to see this really be pushed out and be used in anger. At this stage, there were a lot of Intel developers really pushing Wayland quite aggressively. So by this stage, they'd ported the GNOME shell to Wayland. Later on in 2012, Geneva, the Automotive Alliance, decided that they should officially adopt Wayland as well. There was a lot of work being put into documentation. By 2013, we've hit 1.0 and declared that the client ABI is stable. And then we're sort of really validated by Canonical announcing Mir as a similar but sort of rival Windows system. And that's, I think, when we knew that Wayland was being taken very seriously, because a lot of the reaction was that people felt that they should be using Wayland because by that stage it already had this position as kind of the default and the incumbent. Moving on through into 2013, so the project is now 5 years old at this stage. We're starting to see phones ship with Wayland. We have the XDG shell desktop protocol introduced, given that the original WL shell was only ever meant to be a stopgap. We had Qt Wayland and the Qt client-side Lighthouse stuff announced as general availability and being shipped out and used by real customers. By 2015, GNOME are supporting Wayland in mainline. And at that stage, Christian has quietly stepped away from his role as the founder, the primary developer, the release manager, and he's handed over to Pekka, one of the Collabora developers, as the first release manager who wasn't Christian. And one very small but important point on the timeline is this Wayland protocols repository. Before this, all of the Wayland extension and protocol development was happening inside the Wayland core repository, or it was happening inside Weston in its role at the time as the official reference compositor, was what we'd classed it as. And Wayland protocols was an acknowledgement that the Wayland ecosystem was far larger than these. We had GNOME, KDE, Geneva, Enlightenment, other much smaller window managers and desktop environments, Qt media players. There was just so much going on that we brought out this Wayland repository, Wayland protocols repository, to allow everyone from all different parts of the ecosystem to work on common and shared protocol development and try to head off the fragmentation by having everyone who was working on similar use cases and similar protocols be able to collaborate and work together, which is a lot like the XDG and freedesktop.org standards for X11 as well. By 2016, we're arguably in this quite advanced stage where things are moving quite rapidly. So Vulkan 1.0 launches, and it's had Wayland support in everywhere always. So the OpenStacks, I believe even NVIDIA, they have support just out of the box, no problem. Also, we saw the first release of a tiling window manager called Sway, which sort of built the foundations for the compositor toolkit now known as WL Roots. And in a coincidence at similar timing, Weston decided that it should be more than a plugin system with a kind of small example desktop, and that we needed to make it into this reusable library which others could take and adapt. One of the bigger and more interesting markers as well in 2016 is the Chrome OS team came and announced publicly that Chrome itself contained a Wayland server named Exosphere, and this was how Chrome OS would host Android apps, that Chrome OS would be a Wayland server, and that running inside the Android client container would be a Wayland client. That was the original use case, but it's also been pushed out to support more use cases like running generic Linux in a Chrome OS container. And by 2017, Canonical announced that they would not be investing anymore in Mir, and that they saw the future of the Ubuntu desktop as a Wayland-based GNOME system. And around the same time, we finally managed to get this stable desktop window management protocol. This XDG shell stable release was the first time we had real desktop window management under Wayland. And a lot of things that have happened since then have really happened outside of Wayland and Weston itself. We had some good milestones like landing atomic mode setting inside Weston and using that to push forward the development of kernel mode setting. And that later is one of the things that a reusable framework that I'll discuss a little later called libliftoff picked up from. But then a lot of the work throughout the past couple of years has really been along the margins. You know, they're not big new features or splashy developments. It's things like working on how we deal with external contributors. So moving to GitLab rather than a mailing list based patch contribution system, and implementing a documented governance kind of committee for how we accept things into Wayland protocols and decide on their status and effectively the level of advocacy, and even build systems. So if you're looking at this history diagram, it really does look like there was a huge period of initial excitement and development, and then less development, but more about adoption. And now we're almost in this plateau where there's very little development actually happening on Wayland itself. So to illustrate that, I spent some time with some stats generators and a bunch of JavaScript graphing frameworks until I found the one I actually liked. The first one, if we look at how the commits have changed over time, this is just the number of commits to each repository, and you can kind of see it follows this this trend that I just discussed. So we see Wayland itself being quite rapidly developed. And then Weston, the initial reference implementation with also some sample client implementations, being extremely rapidly developed as we move away from protocol development, as we feel the protocol's largely good, and we work to build out the implementation themselves. And then we see Weston kind of drop off a cliff, really, as its contributor base really declines. The number of changes being made to it massively declines, and people kind of push out towards working on different projects. And that's something that Weston itself has only recently recovered from. And you can also see in the Wayland core repository that there's much less development happening on it as it's entered this maturity and stabilization phase. And this is almost mirrored in many ways by the protocols, where we had an initial burst of excitement and centralization where people started to contribute their protocols and work together to come up with common sets of protocols. And then again, that also peters out somewhat. This graph's looking at the changes in terms of lines of code as well. And again, you can see that apart from a couple of spikes, the Wayland core repository itself in green is really just seeing very small numbers of changes. And even though Weston continues some quite peaky development, the number of, or the volume of change inside Wayland is very small, indicating that it's really about just small bug fixes. And so these are the same with some normalization. These are normalized to a percentage of the peak commit count. So you can see Wayland rapidly declining. And especially in this this graph of the, again, this is a normalized graph, but this time normalized to lines of code which have changed. And you can see that the Wayland development in particular has really entered this phase of just stabilization. And even if we have a reasonable number of commits, they're all changing a very small number of lines of code as we hit this primary bug fixing and maintenance phase. So as a recap of where we've got to, I mean, yeah, we sort of essentially won as a Windows system. You know, Wayland is now taken as the standard for desktops. It's still not fully displaced X11, but it's getting there. But in particular for embedded projects, it's or embedded products, it's the only realistic choice. If you want to do something like a digital signage product or a kiosk, especially in the automotive and in-flight entertainment worlds, and even things like set-top boxes and digital TV, where we've had not just the Freebox, but also products like LG's WebOS TVs shipping using Wayland for some time. And it is now a very mature offering, but as a community, for us, I think we found that transition from the development phase to the maturity phase has been quite difficult. So over the last year or so, we've been trying to rebuild our community along those lines. And yeah, this is largely those stages of development I discussed, where in the central components originally, so Wayland and Weston, we had this really fast-moving, heavy development where there was constant and rapid change. The changes being made were very large. There were a lot of features to add. It was a very fruitful time. And then we saw this real decline as people started to not need to work on the core and not need to work on the reference implementation, but they could go away and they could implement it in their own projects. They could implement it in GNOME, KDE, Qt, GStreamer, you name it. And so it was still the same people, but the development effort was massively dispersed across a huge number of components. After that, we saw this regrouping where people came to share what they'd done. So we had common protocol development, we had bug fixes into the core, we had Weston picking up some of the features which had been developed in other implementations as kind of a reference for best practice. And now that phase is largely finished and the development's gone away again back to the users as people go through and sort of all level up with each other, where they're adding more features that the other ones have and they're working on their own stability and their own performance. And it's kind of this almost second maturity phase. And we're seeing that the core Wayland changes are very much just bug fixes. But we're expecting as well to see relatively soon another small local peak of this re-centralization where people are dealing with things like variable refresh rate displays, complex presentation timing required by both media and some of the game toolkits as well. Better and more complex text input is going to be another fruitful period of this kind of centralization and coalescing. So looking back at that, these are just my own personal opinion takeaways on some of the things that Wayland as a project, as a concept even, really did right. And the things we did along the way, which you can learn from and perhaps emulate even, and hopefully these are good examples for your project. One of the things is that Wayland's always been a very tightly scoped and tightly defined project. It was always it provided you a very minimal experience. And this was the reason for a lot of early pushback to Wayland. You know, people would say, Wayland can't do remote access, it can't do global coordinates, it can't do external window management, and all these things that X11 provided. And that was kind of true, because the way Wayland was developed was with this real focus on just the bare minimum that we needed to get it right. So originally it was very much usable for the embedded IVI and IFE and those kind of single-use systems. And it wasn't developed with doing absolutely everything in mind. And this did bear us well in terms of how sustainable it is. Because if you look at, for instance, the input subsystems between X11 and Wayland, X's is almost unusable. It's incredibly complex. It's the most abstract thing you could ever imagine, which supports every future hypothetical way in which a user could provide input to a system. Whereas Wayland, sorry, is much more limited. It handles keyboards, pointers, and touch devices, and that's it. There's no kind of there's no way for the Wayland core protocol to deal with more complex things like 6 degree of freedom devices or joysticks or gamepads or any of this. But in doing that, we were just very careful about where the complexity lay. So rather than saying you can never do these things with Wayland, we just wanted to make it clear that the place for that was somewhere else, not inside the Wayland core. So it is possible, thanks to the extension mechanism, to build out, there are multiple solutions and have been for years of supporting remote applications on Wayland and remote desktops. There are extensions for complex input devices like gamepads and complex text input and things like these. External window management is something that automotive built out into extensions to fit their model. And it was possible for people to take the core of Wayland and build their specific use case on top of it. And the idea was always that once it was shaken out and once it was proven, if it was a good idea, then it's something we could pull back in. And so this is these repeating cycles we have of the re-centralization, where Wayland serves as a base for people to build on top of and experiment and work with themselves. And then if it turns out to be good, then that's great. We can bring it in later. Yeah, in terms of the world around you as well, this kind of follows on, our ideal world with Wayland was always open drivers with kernel mode setting, ideally Mesa for GPU acceleration, and it was really optimized for this. It was designed to shine in that kind of system, but we always were careful to make it possible for people to run on top of the legacy FBdev display stack, to run with proprietary drivers, which implemented things in a very different way. And the trade-off was that we would show you the best of class, best practice. We would allow you to also run a kind of compromised version and use that as pressure for people to go and do the right things and to re-implement their stacks and their support to actually be best in class, rather than compromising the core by just designing for the lowest common denominator. And a lot of that was almost evangelism as well, where if you look at the early core Wayland developers, they're developers of client toolkits, of media framework, of GPU drivers, of kernel display drivers. And after they'd worked on the initial Wayland core, they pushed out into these communities and went and sort of argued for best practice within those communities and tried to make the best thing happen. On which a little more later. But this also made it usually quite easy for people to try out Wayland and see what it was, because the enablement was very pervasive as we pushed throughout into those communities. Yeah, if you are doing an extensible protocol, one thing we found is it's really important, just like a good API strategy anywhere, it's really important to be clear very early on how you do versioning, something that lets you iterate and extend and at some point deprecate. Just applying enough pressure on people to keep them moving, but not the kind of Kubernetes model where everything changes and you have to go from scratch every 3 months. Yeah, handling leadership transitions as well is always very difficult. Christian stepped back relatively early into the project when it was still very much in this development and almost pre-adoption phase. But the way he stepped back was very, very gradual and very gentle, and it did let other people step up and adopt larger roles and pick things up. And it was something that, as the core contributors, we definitely notice day to day, but if you weren't actively involved in a project, you wouldn't necessarily have noticed he would have stepped away. So just working on a slow and gentle transition phase that lets the project outlive you is really important. And for the project as a whole, the project should ideally outlive your project. When we started with Wayland, it was really difficult to implement a new Windows system. X11 still had a lot of the driver-specific logic for display, for GPU rendering, for input devices and everything, all tied up inside X11. And if you look at the history of Wayland and arguably why Wayland took so long to come to fruition, it's because Wayland wasn't just Wayland. It was developing the generic Linux infrastructure that we all use now and take for granted. Things like DMA buff to exchange pixel buffers between processors. A lot of work on generic kernel mode setting and buffer management for that, so we could have device agnostic clients just write into a generic display API. libinput and libxkb common, which gives us this common base for handling quite complex input devices, all of which were previously tied up in X11. And now libliftoff, which is this layer on top of X11, sorry, this layer on top of kernel mode setting, which allows people to more easily use KMS and actually get the full benefit, but without having to type out the entire thing themselves. And the net effect is that even if Wayland died next week and everyone moved to a new Windows system, Wayland's influence will have still massively outlived the life of Wayland, because all of this common infrastructure that we've created allows anyone to quite easily create a new Windows system. Even in toolkits, you feel the effects where a lot of the work to enable Wayland was really a lot of the work to rewrite toolkits like GTK and Qt, so they could better work across multiple Windows systems. And this is great because it keeps us honest. It doesn't put Wayland in this privileged position where it would be another once in a generation transition to move away into a new Windows system. It's actually really easy. Anyone is free to go out and experiment and build on top of all this infrastructure and create a competitor to Wayland. It's not a problem at all. But doing this, it gives you a real fruitful place for other people to experiment and to push you and challenge you. And that's one thing we've always felt is really important, is the ability to burn down your own castle and not just create the same thing we saw with X11, where everything was so tied up in your project that it's impossible to replace, and it continues to exist only because of inertia. That being said, there's some things we didn't do so well. And if you're looking to us for examples, you should probably try and do better. Documentation has always been an issue with Wayland. We really struggled in that we do have very clearly and concisely and accurately documented protocols, which will tell you for every single protocol call what the acceptable conditions are and how to use it. But there's nothing that ties it together. So we have the reference material, but we even have quite a few examples for most of them. There are some fairly clearly written examples. In particular, Weston has this suite of example clients which shows you how to use Wayland. But we really lack the kind of narrative style documentation which ties everything together and takes you through, as someone who doesn't know Wayland, the whole ecosystem and how everything should hang together and some of the overarching concepts. A lot of this has been because quite early on, there was a pretty concerted effort to give us this documentation system which no one understands. It's completely Byzantine, and moving away from it has been really frightening, almost as frightening as trying to contribute anything into it. So I think in particular for documentation systems, just like build systems, it's important to pick something which is easy to understand, which is very trackable and quite common, so you can get those contributors. The only way we've been able to bridge this gap is presentations do turn out to be a really good way to define your narrative. But equally, in the absence of anything written, you'll be in this tension between the presentations defining a narrative, but also comment sections defining a narrative. If there's an absence of proper information, and people are going to speculate and borderline just make things up. So it's really important to look at those three styles of and classes of documentation and make sure that you cover them well. Toolkits beat mid-layers is an example or a lesson that we took from kernel mode setting. Daniel Vetter has some really good, more technically focused talks on exactly what he means by the distinction between toolkits and mid-layers. I'd really recommend checking that out if the terms are not familiar. But essentially the difference is, if you look at the two main non-desktop compositor toolkits that exist today, there's libweston and wlroots. wlroots has this very piecemeal approach where they give you access to a bunch of functionality and a lot of helpers, and it's up to you to piece those together and to pull it all in and sort of stitch things together yourself. libweston takes the opposite approach. It originally only provided you a plugin system where you could plug in and take some defined callbacks and listen to some signals, but it was only ever you would get control when the core wanted to give you control, and you could only control the things that the core let you. It was very much the core was in control and sometimes dipping up to you, whereas wlroots has this inverted toolkit approach where you're always in control and pushing down into the core when you think is a good idea. The toolkit approach is almost always better. wlroots has a huge user base of people who originally tried libweston and then just gave up because the mid-layer approach just didn't work for them, which is kind of sad to see. But we're gradually rewriting libweston to be more of a toolkit-centric API, but once you've established yourself as a mid-layer, it's incredibly difficult to row back from there. It's years and years of work, and kernel mode settings been through the same experience. But if we look at the protocol, it seems obvious that we should have been following this DIY toolkit type approach the entire time. The protocol is a bunch of tools that are available to you that you can take and stitch together to achieve what you want to do. It's not this big overarching prescriptive framework. So really, in hindsight, we should have looked at the protocol and what made the protocol successful, which was this toolkit approach, and followed that. It should hopefully be quite obvious that you've got to have an appropriate barrier to entry. This is one of the reasons we believe why we saw Weston have such a large decline in contributors alongside Wayland. Weston shouldn't, according to the cycles and the periods we went through, have had a decline. It should have had an increase, or at least a stable number of contributions and contributors. But we had this quite high barrier to entry. It worked really well originally when Wayland was essentially being built by Collabora, Intel, Red Hat. We had a small number of people who all worked together day to day, and it was very easy for us to iterate rapidly. But as we hit this adoption cycle where it was being picked up and worked on by a larger number of people, we failed to realize at that point that we needed to reduce the barrier to entry and optimize it more for kind of one shot or drive-by contributors rather than a very small day-to-day focused dev team. And this took us far too long to realize and action. So that made our transition to maturity really difficult, because we were getting good bug fixes and we'd just drop them on the floor because our contribution process was too painful. And if you look at the contribution graphs since we've transitioned both Wayland and Weston to GitLab, you can see there's this enormous uptick where people have come back now that they don't have to use mailing lists, and they can use a reasonable modern contribution approach with tracked change requests and CI and all of this. So yeah, it's really about making sure that people are empowered and that they feel empowered to contribute, and that you're not scaring them off, and you really think about what's appropriate for what stage of your project and who you're optimizing for. Yeah, the testing and validation largely suffered from the same error as our documentation. We had some people who were very excited about writing test suites. So instead of using a common test framework, we had this hand-rolled, completely unknowable, custom-built framework, which was completely unmaintained as soon as the person who had originally wrote it had moved on to doing something else. And it never fully got adopted. So we again had this issue where it should have been as easy as possible to contribute tests, but we didn't have a good base for tests. We didn't have good examples and references to work from, and it wasn't easy to build complex tests. So this is something we've been dealing with the damage of, and Pekka spent several months going back through and redoing all of the test frameworks to make sure we've got this really solid base where it's very, very easy for people to write their own tests, and essentially that you have no excuse to to avoid testing. previously it was really easy to not write tests because you could just say, well, it's too hard to do it, so I'm not going to. Yeah, I think the most salient lesson from all of it is I originally broke down Wayland into those kind of prehistory, Stone Age, Bronze Age stages as a bit of a joke. And then because it seemed to surprisingly nicely fit into chunks of six time points, and then I realized as I was writing it that was probably the most important thing, that Wayland as a project has moved through a lot of different stages, and at each stage we've had completely different audiences to address in terms of both users and developers and contributors as well. And that's the thing I think is most important to be taken away, is to periodically just sit back and reset and try with as few background assumptions as possible. Just look at the world around you and the context you exist in, and try to make sure that everything you're doing is appropriate and optimized for that environment you're in. We honestly did a fair bit of harm to Wayland by not having collectively as a community done that. And it's a good community health exercise, which you should be doing, and just making sure that you're still doing the right thing rather than just limping on with something just by inertia, even if it's completely inappropriate for what's now your new target audience. And with that, I am out of material. I'm not sure if there are any questions or.
We have one question in the chat.
Sure. If I can see it.
So let me read it out for you. So the question is there a simple way to know if a particular program is using Wayland?
The easiest one probably is in the environment. You can set the Wayland_debug variable, set that to client or 1. And if it is using Wayland, then it will spit out a huge amount of debug to stand it out. If it's not, then it won't.
Okay, thanks.
So I think that was it.
Yep. Okay. Thank you very much.
Thank you,
Thanks very
Daniel.
much.
Yes.
Daniel, highly appreciated. Thanks.
Thanks
Thank
a
you.
lot.
Thanks,
Bye-bye.
everyone. Bye.
See you guys.